Kia ora koutou katoa, it's Mrs. Goodson here, and this video is about writing a conclusion and writing a discussion for a chemistry investigation. And our chemistry investigation is about rates of reaction. First of all, what is a conclusion? A conclusion is when you identify the overall trend from your results. So in an earlier video, we looked at processing the data so that we had some results, and we're looking for a trend. And you might put a statement in whether you accept or reject your hypothesis. So you need to say, what is the trend? It's only short. A conclusion only has a few sentences, and you link back to your hypothesis. Was it right or wrong? When we look at our graph, we usually see if there is a relationship based on how easy it is to put a line through all the points, and then we call that line the line of best fit. So a line of best fit goes through the middle of the data points and it shows the trend. If there is a strong, weak, or moderate relationship, or no relationship, is the relationship positive or negative? If you can draw a single line that goes through all the points on your graph, like in this example here, over here, then it is probably a strong relationship. The closer the dots to the line of best fit, then the stronger the relationship. If you can't easily draw a line through, and there seems to be but there still seems to be a connection, this overall trend, then we say it's a weak or a moderate relationship. So just look at how close the dots are to the line. The closer they are to the line, the stronger the relationship. If there doesn't seem to be any connection between the two variables, it looks random, then there's probably no connection between the variables. And so this is an example between shoe size and IQ. It's just random. The dots are just random. There's no pattern, no trend that we can see. So just this is a summary of the types of correlations. So a positive relationship will have a line in this direction. A negative relationship has, or an inverse, sometimes we call that an inverse relationship, it goes this way. And a no relationship means that you can't draw a line of best fit. Positive relationships, so as the dependent variable increases, if the dependent variable increases as the independent variable increases, then there is a positive relationship. If the dependent variable decreases as the independent variable increases, then there is a negative relationship, as in this graph here. So as pressure increases, volume decreases. In the experiments that we've been doing in the school lab, we've been looking at the temperature of sodium thiosulfate. We've been looking at the concentration of sodium thiosulfate. We've actually get a curve of best fit. So we can draw a curve. And this shows a negative correlation. So the overall trend line would be, it's not very straight, but you get the idea. The overall trend line is negative. Where's my pen? Okay, so it's going a negative there. And the pen, there's the pen. Okay, so a negative correlation. Could draw a trend line that would look like that. So that means as the time for it to react increases, the temperature is decreasing. Now the independent variable is actually the temperature or the concentration. So the higher the temperature, the shorter the time for the cross to disappear, and so therefore then we need to link it to rate. Okay, so talk about this a bit further on too. In our aim, we talk about rate, so make sure we link time to rate. For example, if in this graph here you see as internet usage increases, the age of the person decreases. So we could write it as, we found that as the internet usage per week increased, the age of the person decreased. There was a moderate negative correlation. My hypothesis was correct. Just to elaborate more about time and rate. The time for the reaction to occur is what we're going to measure, the time for that cross to disappear. But we're really interested in rate, and that's what's in our aim. So the longer the time for the reaction to occur, the slower the rate of reaction. You can use those words, longer and shorter for time, and slower and faster for rate. In our aim, we talk about rate, so we need to answer this in the conclusion. First, talk about how the independent variable, for example, the temperature of solution A or the concentration of solution A increases, then the time for the cross to disappear increases or decreases, and if the time increases, then the rate is going to decrease. If the time decreases, the rate increases. So that's an inverse relationship between, opposite relationship between time and rate. Just make sure that in your conclusion, you talk about time and then you talk about rate. So, what about the discussion? The discussion is part of your investigation report that explains your conclusion by linking your results to your knowledge of the relevant science ideas or the relevant chemistry ideas in this example. So, you need to explain what happened and the trend you observed. You need to link what happened to your understanding of the chemistry. So you really need to study up on the science ideas. In this case, it's rate of reaction. So there's a few videos and PowerPoints about particles, reactant particles, collisions per second, and how that's related to rate. And in your discussion, you need to link that to your results. So you need numbers with units. Now, these words are going to help you write your discussion well. So because you want to explain why, you need this word because, also therefore, compared with, according to, even little words like as or due to or since, just are linking up the ideas, which means that this tells us that as, I think I've got that one twice. So, which shows that, this indicates that. So, we can say that this means, therefore, shown by, which leads to. So, all of these words help link, and that's what we're looking for in your discussion. We're linking the science ideas to your conclusion. So you want to be able to write a discussion. So we're looking for 3 paragraphs approximately. You're linking the conclusion and the data. You need to state your own data with units. So a couple of examples. A good starting point is to define particle theory and define collision theory. So particle theory is that all matter is made up of particles that are constantly moving, and the more energy they have, the faster they move. And then collision theory is that in order for a reaction to occur, that the reactant particles have to collide with sufficient or enough energy and at the correct orientation. And then you need to link to your investigation what happened with the reactant particles. So if you increase the concentration, you're increasing the particles per unit volume. So the particles are closer together. Therefore, there will be more collisions per second, and therefore you are increasing the rate of reaction. Now, if you're increasing the temperature, then there are more the particles are moving faster, and the particles have more kinetic energy. So therefore, there are more collisions per second, and they're more likely to be successful, and therefore you increase the rate of reaction. Just a reminder of how particles and collisions link. So these are the 4 things. Now this relates to our external as well: temperature, concentration, surface area, and catalyst. So temperature, the particles are moving more quickly and have more kinetic energy, so there's more collisions per second and they're more likely to be successful. Concentration, there are more particles in the same unit volume, so there's more collisions per second. If we've got some sort of solid like our marble chips, and then we turn it into a powder, then we've increased the surface area and there are more particles exposed, so therefore there will be more collisions per second. And a catalyst provides an alternative reaction pathway which lowers the activation energy. And so if you use a catalyst, if you can, then the collisions are more likely to be successful, and so therefore the rate increases. So this video has been about writing a valid conclusion based on an interpretation of the process data that links to the purpose or the aim of the investigation, and write a discussion, that part of the investigation, that links your results to your knowledge of the relevant science ideas, in this case, the chemistry ideas about rate of reaction.